So here DES stands for Data Encryption Standard. The actual length of the key is 64-bit, but in DES I'm going to consider only 56-bit and I'm going to discard last 8-bit. So when I consider any DES, that must include round function, key scheduling algorithm as well as initial and final permutation. Hello to all, a warm welcome to my new session on traditional symmetric key cipher. I am Revati from the Department of Computer Science, Vidhyaashram, First Grade College, Temple of Excellence, MYSURU. So dear student, before going to start my today's session, let me to recall the things what I have covered in my last session of this unit. So there I discussed difference between substitution and transposition cipher. That means how the substitution cipher as well as transposition cipher is going to vary. Along with that, I discussed what is stream cipher, how to perform stream encryption as well as how to perform stream decryption. These are the important topic I have covered in my previous session of this unit. So dear student, from the examination point of view, these two are very important topic. Now in my today's session, at the beginning I'm going to deal with DES. So what is this DES? What is the need of this DES? Along with the structure of DES as well as how to perform round function as well as how to generate key, all those things we are going to discuss in my today's session. So dear student, don't forget to watch this session and don't forget to make a note, because this is also very important topic. That means you can able to expect one question from DES or AES. It's a sure question. So you can able to expect one question from DES or AES. But at present in this session, I'm just going to deal with DES. So what is this DES? That is nothing but data encryption standard. So here DES stands for data encryption standard. Let's see what is DES. So dear student, I'm going to mark it as important question. It's sure question. You can expect either DES or AES. Now, what is DES? There's nothing but data encryption standard, and it is example for symmetric key block cipher. I repeat, it's example for symmetric key block cipher. Now tell me, what is symmetric key? That is, single key is shared between sender as well as receiver. That means to encrypt any plain text, same key is used, and to decrypt ciphertext, once again the same key is used, and that kind of cryptographic systems are termed as symmetric key block cipher. So here inputs are in the form of blocks. That means plain texts are treated in the form of blocks, and it was published by National Institute of Standard and Technology. That means it was introduced by National Institute of Standards as well as Technology. So in short, it is called NIST. So here this DES, that is data encryption standard, is mainly based on the Feistel cipher. So it is mainly based on the Feistel cipher. So what is this Feistel cipher? In this Fiscal cipher, we are going to have the rounds. That means it includes certain rounds. Once again, in our DES, we are going to use rounds. That is round function. It uses 16 rounds. That means if I consider fiscal cipher that includes 16 rounds, once again in our DES, we are going to use 16 rounds. For that, DES is mainly based on fiscal cipher or fiscal structure. And what is the block size here? It is 64 bits. That means the input, that is plain text, is considered in terms of 64 bits. So it's going to take blocks. And what is the size of block? Here it is 64 bits, as well as the length of the key is 64. So dear student, please remember here that the plain text size is 64. I'll write P and it is 64. And what about key? I'll write K and it is 64. And if I consider these numbers, it is nothing but the multiplication of 8. For example, if I consider this 64, I'm having 8, 16, after that 24, after that 32, after that 48, and 56 and 64. Now, dear student, please remember one thing here, that the size of the key is 64. When we consider the key size 64 and when we apply key, then we are going to discard last 8 bit. That means we are going to discard last 8 bit, that is 64. So here, the key length is 64. The length of the key is 64. But in DES, we are going to consider the key length 56. So dear student, please remember here, the size of the key is 64. But in DES, we are going to consider only 64 bit. So here, DES has an effective key length of 56, since 8 bit of the 64 bit of the keys are not used. That means out of 64, I'm going to consider only 56, and remaining 8 bits are I'm not going to use. So dear student, this is the general structure of data encryption standard, and as I discussed, it includes 16 rounds. It is based on 16 rounds, that is nothing but based on the fiscal structure. So at the beginning, I'm going to have the permutation, that is initial permutation, and I'm going to have the round 1, round 2, up to round 15 and round 16. So dear student, please remember here that okay, the length of the plain text is 64 bits, and that is the input to the initial permutation. And in the initial permutation, the input 64 bit is divided into 2 different parts, that is 32 bit left half and 32 bit right plain text. The left half is 32 bit and the right half here is 32 bit, and that is given to the round function. So that is given to the round function. Now, if I consider key, what is the length of the key here is 64 bit. But I'm going to consider only 56 bit key, and when I apply round key generation function, after that I'm going to get only 48 bit key. I repeat, the actual length of the key is 64 bit, but in DS I'm going to consider only 56 bit and I'm going to discard last 8 bit. And when I apply round key generation function, I'm going to get the output, that is 48 key. And for each round function, I'm going to give 48-bit key. So what is the length of the key here? It is 48-bit. So this is for first round function, and next 48-bit key for second function, and it is going to continue up to 16th round, and at the end I'm going to have the final permutation. I'm going to have the final permutation. So in the final permutation, what I'm going to do, I'm going to club all the left half as well as right half plain text in order to get my final 64-bit ciphertext. So this is the general structure of DES. Now see here, I'm going to have the DES, which is mainly based on the Fiestal cipher. So which is mainly based on the Fiestal cipher. When I'm going to use Fiestal cipher, that includes round function, key schedule, as well as initial and final permutation. So when I consider any DES, that must include round function, key scheduling algorithm, as well as initial and final permutation. So here at the beginning, I'm going to have the initial permutation. Dear student, just remember here that if I consider DES, what is the input size? It is 64 bits. And when I apply the 64-bit to initial permutation, the 64 bits are divided into 232 bits. That is left half 32-bit and right half 32-bit. So here the initial and final permutations are straight permutation, that is called P box, and that are inverse to each other. That means in the initial as well as final permutation, I'm going to get the input. And if I consider initial permutation, so at the beginning itself I'm going to get the initial permutation, and what's the input for initial permutation? That is 64 bits. Now what is the job of initial permutation? Divide the 64-bit input into two 32-bit input, that is 32-bit left half and 32-bit right half. So here I'm going to have first 32-bit left half and next 32-bit right half, and this is the input to the random function. So how many rounds I'm having here? Total 16 rounds. So this is the input to the round function, and how many rounds I'm having? That is 16 rounds. After that I'm going to get the final permutation. In the final permutation, I'm going to combine two 32-bit plain text in order to get my ciphertext. Now, if I consider round function, it is called heart of the cipher. If I consider any round function, it is termed as heart of the DES. And the DES applies 48-bit key. See here, usually I'm going to have 32-bit, and when I apply expansion P box, I'm going to add 16-bit to 32-bit. So I'm going to get the output 48-bit. What is the input bit I'm having here? That is 32. For that, if I add 16, so I'm going to get 48-bit. That means this P block is going to expand 32-bit in order to get 48-bit. Now I'm going to perform XOR operation. And if I consider S box, there are 8 S box. So here there are 8 S box, and what is the capacity of each block? It is 6. That is 6 bits. So here I'm having 8 S box. So 1, 2, 3, 4, 5, 6, 7, 8. So what is this S? That is nothing but the substitution block. And if I consider P, it's nothing but the permutation block or permutation box. And here if I consider substitution box, so here I'm having 8 box. Now the capacity of each block is 6 bits. So 6 into 8, it is 48 bits. 48 bits. After performing substitution box, I'm going to get the output 32. So what is this 32? That is nothing but I'm going to have the block size, that is 4. So I'm going to get the block size output 4. 4 into 8, it is 32. So when I provide input to S box, that is substitution box, the block size is 6 bits. After performing S box, I'm going to get only 32 bits. That means the block size is going to decrease and the block size here is only 4 bytes. Now I'm going to perform straight permutation block or straight permutation box, and I'm going to get only 32 bits. So this is the way the round function is going to perform its operation. So here I'm going to get only 32 bits. So after performing round function, each half is responsible for producing 32-bit output. Now that is expansion permutation box, that is nothing but the permutation box, since right input is 32 bits. That means if I consider input 64 bits, then it is divided into 232 bits. So here I am going to consider only right input 32 bit, and I am going to apply 48-bit round key, and I need the output. That means I am going to get the output only 32-bit. Now I am going to have the XOR operation. After the expansion permutation, DES goes through XOR operation and expands the right half. Round key is used only in this function. Now here if I consider substitution box, the S box carries out the real mixing. So what is mixing here? That is nothing but the confusion, or it is called substitution. And if I am going to perform transposition, then it is diffusion. But here I am going to perform substitution. For that reason, it is called confusion. So here DES uses 8 X box, each of the capacity 6 bits input and 4-bit output. That means it's going to take 6-bit input and it's going to provide only 4-bit output. And here X box, there are total 8 S box table, and output of S box is 32-bit section. And this 32-bit output of S box is then subjected to straight permutation. And what is the output I'm going to get? I'm going to get 32-bit output. So this is the overall working procedure of general structure of DES, as well as how this round key is going to generated. So this is all about how we can able to perform round function. Now I'm going to have the key generation. So how I can able to generate key, and this is the way I'm going to generate key. So if I consider DES encryption algorithm, what is the length of the key? Here the length of the key is 64 bit. But I'm going to use only 56 bit and I'm going to discard last 8 bit. That means I'm going to discard last 8 bit. And when I apply this 56 bit key to key generation function, I'm going to get only 48 bit key length, and this is the input to all 16 round function. So this is the input to the all 16 round function. And if I consider this diagram, see here, I'm going to have the 64 bit. Okay, that is given to the parity drop, and it's going to drop last 8 bits. So after dropping last 8 bits, I'm going to get only 56 bit. So this 56 bit is once again divided into 28 bits as well as 28 bits. Now here I'm going to perform permutation box, and this is the first round key. So what is the key length here? It is 48. That means after performing compression permutation box, I'm going to get 48 bits key. And if I consider second round, once again I'm going to get 48 bits key. And if I consider last 16 round, once again I'm going to get 48 bits key. That means this 48 bit key is common for all round function. That is, for round 1, what's the input? 48 bit key. And for round 2, what is the input? It is 48 bit key. And for round 16 bit key. So this is the way I can able to generate keys in DES algorithm. So dear student, from the examination point of view, this DES is very, very important. So you're going to get the direct question like explain DES and explain its working procedure. In that time, you want to explain something about DES, then write the DES structure. Along with that, please write the input format. That means how we are going to provide the input, how we are going to generate the key, etc. So this is all about today's session. So dear student, in my today's session, you got more information about DES. Let's meet in the next session with AES, that is Advanced Encryption Standard. So in the next session, I'm going to deal with AES. And from the examination point of view, this is also, and today's topic DES, also very, very important. So dear students, let's meet in the next session with some more information about Advanced Encryption Standard. Until that, keep watching and keep learning. Thank you.